Are you tired of graphing? I figure you are. I know graphing takes a long time. It's not very fun to do. But today we are going to start learning other ways to solve quadratics where we don't have to graph every time. Today we are going to learn how to graph, or how to solve quadratics by factoring. Just ignore the little date up here. When I saved the PDF, I forgot to take my date off, okay? Now, in order to solve by factoring, we have to know what is called the zero product property, okay? And we start out with this. If A times B equals 0. I have a product, and that product equals 0. If I am multiplying two things together, and the answer is 0. I'm multiplying two things together, and the answer is 0. What has to be true? Well, to get 0 as an answer, then either A equals 0 or B equals 0. If I'm multiplying two things together and I get the answer of 0, one of the factors has to equal 0. That's going to help us to solve quadratics, okay? So keep that in mind. That's what we're using on every problem we do. Now, here we have a quadratic. Y equals x squared plus 3x minus 10. We could graph this. We could find the vertex. We could graph. We could find what the solutions to this quadratic are. But we don't want to graph anymore, okay? So recall, what did we say were some other words for the solutions? The solutions of a quadratic are the roots. They are the zeros. What else? There's one more word. They are the x-intercepts, right? Now, this is what we want to focus on. What does it mean to be an x-intercept? Well, that means it crosses the y-axis. What is true of every point on the y-axis? If they're the x-intercepts, then y has to equal 0. Okay, if they're the x-intercepts, then y equals 0. I think I mentioned in the last video, that's one reason we call them zeros, because it's where y equals 0. So what I've actually got here, if I'm trying to find the x-intercepts, then instead of y equals x squared plus 3x plus 10, I can have 0 equals x squared plus 3x plus 10. Okay, now, I don't really like it written that way. You don't like it written that way. I'm going to reverse just because. Whoops, it should be 3x minus 10. You thought you got me, didn't you? You didn't. All right, eraser. It's not going to let me erase. I never know why it does that. Okay, this is wrong. This should be minus 10. And I'm going to say equals 0. The whole point of that was to move 0 to the other side. Okay, so your first step is that the equation has to be set equal to 0. All right, that's the first step. Now, the second step, what we want to do next, notice I have a trinomial here. What do we do with a trinomial? What did we do in the last chapter with a trinomial? We factored. So step 2, I told you, you can never forget factoring. Factoring is going to follow you. You're going to factor this trinomial. So what will give me x squared? X and x. If my last term is negative, what does that mean about my signs? One's positive, one's negative. So I need two numbers whose signs are different. The product is 10, and the sum is 3. What's that going to be? Or negative 10 and a positive 3. So I've got what? Plus 5 and minus 2. Does that work? 5 times negative 2 is negative 10. 5x minus 2x gives me 3x. Okay, so I factored it, which means what? Write as a product. So I have something times something equals 0. Well, what does that mean about these two somethings? That means one of them has to be 0. So the next step is to set each factor equal to 0. Okay, so here's what you do. You set x plus 5 equal to 0, or that's got to be 0, or x minus 2 has to equal 0. One or both of those has to equal 0 in order for the product to be 0. Now you've got these nice little easy no-brainer equations that you have to solve, okay? If x plus 5 equals 0, then x is negative 5, or x is 2. So there are our two solutions. This parabola crosses the x-axis in two places. It crosses at 5 and 2. Okay, we know it's pointing up, right? So it's down here somewhere, okay? We don't really care. But those are the two places it crosses the x-axis, 5 and 2. All right, now let's do a couple of other examples. Here I've got a quadratic. Notice that they have already set it equal to 0. They've done that for us, okay? So that was step 1, was set it equal to 0. Step 2 is what? Step 2 is factor. So I'm going to factor, and I get x and x. These have to both be plus. Factors of 3 that add up to 4, 3 and 1. Okay, so this one factors to x plus 3 times the quantity x plus 1. Then you take each of those factors, each of those parentheses, and set them equal to 0. So either x plus 3 equals 0 or x plus 1 equals 0. These are one-step equations. I'm going to subtract 3 from each side. So x equals negative 3 or x equals negative 1. Okay, so that's the two places this parabola would cross the x-axis, would be at negative 3 and 1. Okay? All right, let's look at one where the signs are a little different. Let's do number 4 here. Factor it. It's already set equal to 0. So x and x. My signs are different. I need factors of 27 that I get 6 when I put them together. I think that's going to be plus 9 and minus 3, right? So you factor. You set each one equal to 0. You solve. X equals negative 9 or x equals 3. That's the two places that parabola crosses the x-axis, right? Whole lot better than graphing, don't you think? Okay, now let's go down to number 9. Let's look at number 9. What's up with number 9? It's not a trinomial, right? But we can still handle this. What did I tell you was the first thing you needed to look for when you are factoring? This one has a GCF, right? So what's common to x squared minus 8x? We're going to take that x to the outside. What are we left with? X minus 8. So now my two factors are x equals 0, or x minus 8 equals 0. All right? X minus 0 is already solved, already done. Don't have to do anything with that. This other one, x has to be 8. So my two answers are 0 and 8. All right? I want you to do a few. Why don't you try 2, 6, 8, and 10. You try those. Turn the video back on. Check your work. Okay, I got x equals negative 3 or x equals negative 8 on number 2. I got x equals 5 or x equals negative 4 on number 6. Both of those were pretty straightforward. Number 8's a little different. Notice you got the same factor. So the only solution to this is 4. What does a parabola look like that has one solution? Do you remember? It would actually be on, the vertex would be on the axis, right? It would be like this. This one's pointing up. So it would be something like that. Okay, so that one's actually on the x-axis, or the vertex is on the x-axis. And then this is another one sort of like number 9. X is 0, or, I forgot my word, or x is negative 5. Okay? If you have any questions, make a note of them, and we'll see you in class.